Hey guys, so I want to do a big lesson and a kind of review. There are a lot of videos that I would like you guys to watch this week, just kind of reviewing the ionic and molecular compounds. So to emphasize, ionic compounds are between a metal and a non-metal. So something on the left-hand side of the periodic table with something on the right-hand side of the periodic table. Metal plus non-metal. With ionic compounds, you have an exchange of electrons. Your metal gives electrons to your non-metal. So those are ionic compounds. Some characteristics and properties is that they're good conductors of electricity, they're solid at room temperature, and they're also good conductors of heat. And then when we get to molecular compounds are between two nonmetals. So two things that are on the right-hand side of your periodic table. And molecular compounds or nonmetals, they typically would receive electrons from a metal. So what they do is they'll actually share electrons. Two nonmetals will share electrons. And that sharing of electrons is called a molecular bond or a covalent bond. You can use either term. And so they're called molecular compounds because they're two elements that are sharing electrons. They're two nonmetals. Okay. So when we got to naming ionic compounds, I think it's best that I first show you how to write a formula for an ionic compound. And the videos, the Tyler Dewitt videos, I would like you to watch them. There are a lot of them, but I think he teaches it almost better than I can virtually. Okay, if I was in person, obviously, but he does a great job of giving you lots of examples. So please watch his videos. So ionic compounds, if I'm writing the formula, and this is why I want you to watch the Tyler Dewitt videos, because he's able to show you his page as he's working through an example. But you are going to have to look at the ions. So if I gave you sodium chloride, for example, I gave you the name, okay, and I wanted you to write the formula for sodium chloride. You would go find sodium on your periodic table. So we're going to look here. And sodium is number 11, Na. And you can see that its ion charge is +1. So you're going to write Na with its charge like this, Na +1. And then you're going to find chlorine. So chlorine is a nonmetal because we're looking at ionic compounds. So it's number 17 here. And it's -1. So you're going to write the symbol Cl and then -1. Okay? Now what I like in the Tyler Dewitt videos is he kind of creates almost like a math equation. And so what you're going to do is you're going to kind of add up your charges and see what they are on both sides. So you have +1 for sodium and -1 for chlorine. So when a metal and a non-metal meet to form an ionic compound, they kind of negotiate and they come up with an exchange. I'm going to give you 1 electron and you're going to accept 1 electron. And they come to that agreement. And the reason is because they have to become neutral. They have to equal 0. So right now, if you were to put in your calculator +1 -1, you would get 0. So what this means is if you have 1 sodium and 1 chlorine, that they will neutralize each other and equal 0. So this is not a formula yet. What you're going to do is you're going to bring these two elements together. Okay? So you're going to write Na and you're going to write Cl, NaCl. You notice that I don't have the charges anymore. I've eliminated the charges, okay? Because they're neutral, I don't need them. And so when we write NaCl, this is a formula, okay? And something to note is that what this means, okay, as a chemist, is that you have one sodium, one atom of this element, and one atom of chlorine, and they neutralize each other. You notice that they don't have a charge, okay? We don't write ones, okay, in the subscript here, okay? They're invisible. So your formula for sodium chloride is just NaCl, okay? So if we do another one, let's say I gave you magnesium fluoride, okay? If I gave you the name and I want the formula, you have magnesium and fluoride. You're going to find magnesium on your periodic table. So magnesium is in group number 2, family number 2, number 12. It is Mg, that's the symbol, 2+. So this means that magnesium really wants to give up 2 electrons, and it's going to be looking for someone that's willing to accept 2. Okay? So I have Mg2+, and then I have to find fluorine. Fluorine is a halogen, it's a non-metal, it's number 9. It's F for the symbol, and then -1. So I write it like that. Okay? This is not the formula yet. So, just like Tyler do it, I want you to add up your 2 sides. So I have +2 and -1. Okay? So if I have 2 plus over here, -1, I'm still going to be then -1. Or sorry, +1. Yeah, 2 minus 1 is +1. So, when looking at this, I'd like you to picture which side should you add to. Should you add another magnesium, which would make it 4+? Or if you add another fluorine, will that then make it 2-? And 2 plus -2 would give you 0. Okay, so hopefully you know we'll add another fluorine here. So if I add another whole fluorine atom, okay, I then have -1, -1, which should give you -2. Okay, so now 2 minus 2 gives you 0. Okay, so now you can bring these 2 together and tell me how much you have of each. Okay, so you have, I'll try and put it on this page. 1 magnesium, just 1, so I just write Mg, and you actually have 2 fluorine. So you're going to write the symbol and then a subscript 2, right there. Okay? So what that means to a chemist, okay, is that you have 1 magnesium atom, there's an invisible 1 there, and you have 2 fluorine atoms. Okay? And then they're neutral. There's no charge, they've neutralized each other. Okay? A trick, okay, to this, and I'd like you to practice the way I'm doing it and the way Tyler doing it. But a trick is called swap and drop. And so if you were to write the charges, again, of magnesium 2+ and fluorine, okay, what swap and drop is, let me see if I can do this, can't do it. Like that. What you're going to do is you're going to take that 2, drop it over here, 2, take this 1, drop it over here, don't write 1. And when you bring this together then, you have Mg with an invisible 1 there, and fluorine now with a 2. Okay? So that would also work. If you write the ion charges of both your elements and then drop their charges, you don't keep the pluses or the minuses, just the numbers, you'll be correct. Okay? So if we do one more, let's do lithium oxide. Okay, going to find lithium, number 3 on your periodic table, Li plus 1. You're going to find oxygen, number 8 over here, so it's O2 minus. Okay, if I do swap and drop, okay, if I did swap and drop, you would then have Li2 and O1, which would be correct. Okay, if you just drop the charges. Okay, but if we do it the long way, just to make sure we're right, okay, you have 2 oxygens and only 1 lithium. So in order to balance this, which side should you add to? Lithium or oxygen? Hopefully you said lithium. Okay, so if I add 1 more lithium, I'm going to have plus 1 will give me plus 2. Okay, so then 2 minus 2, 0. So now we just bring them together, and you're going to tell me that you have 2 lithium and only 1 oxygen. So it's Li2. Li2O. Good. Okay. So that's how we're writing the formulas. The other component were multivalent ions here. Okay. So multivalent ions are all your transition metals. So like copper, nickel, manganese, iron. You notice that they have 2 options here. Okay. And so when we're writing the names and the formulas, it's important that we know which one is correct. Are we using iron 3 plus or are we using iron 2 plus? So if I'm writing the formula for something with a multivalent ion, let's say I do iron sulfide. Think for a minute there. Okay, so if you have iron sulfide, and I said iron 2 sulfide with the Roman numeral there, okay? So what that means is when I go to look at iron, I'm going to pick the one with 2, okay? So I'm going to go Fe 2 plus, not 3 plus, because I put 2. And then you're going to find sulfur. Sulfur is number 16 over here. It is S2 minus, okay? So one trick or one rule, or it's a rule, is that if I were to balance this, I have 2 plus over here and then minus 2, that equals 0. Great. So really, I only have 1 iron and 1 sulfur. And if you did swap and drop here, you'd be incorrect. Okay? So you need to tell me that you only have 1 iron and 1 sulfur. So you're going to write Fe, no number, S, no number, FES. Okay? Because these 2's up here, they cancel each other out. Okay? In chemistry, if I wrote Fe2, S2, no good. This would be redundant. Okay? You don't need to tell me that you have 2 atoms of iron to neutralize 2 atoms of sulfur. You would just write FeS. Okay? And so if I gave you this as the formula, it's very challenging. This is something more like grade 10. You would then have to find the name. And how would you do that? Well, you'd find Fe, which would be iron, and you're not sure yet if it's iron 2 or iron 3, okay? So you're going to then go find S, and you find that it's sulfur, okay? And so with ionic compounds, the rule is you name the metal, and then you're going to change the ending of the non-metal to IDE. So it's iron sulfide, okay? And so an extra step that you would have to do with a multivalent ion is then go see what the charge is for sulfur. And the fact that it's 2 minus, and I'm showing you that you have one of each, so it neutralized, you can assume that iron was 2 plus, okay? And so then you would put iron 2. So your name is iron 2 with the Roman numeral sulfide. And then IE. Okay? So that is also naming ionic compounds as well as writing the formulas for ionic compounds. There is a video that I would like you to watch from Tyler Dewey that talks about these polyatomic ions. Polyatomic ions are groups of elements that have a charge on their own. Okay? So an example is, let's do chlorate. Chlorate, okay, is a polyatomic ion. You notice that it doesn't end in IDE like chloride, but ATE. Okay, so chlorate, okay, you are always going to be given this list of polyatomic ions. You never have to memorize them. And so if I asked you what the formula for chlorate was, you would put ClO3 with a charge, because this group, this compound actually holds a charge. They are more negatively charged. So it's chlorine and oxygen with a negative charge. And so what this means, Cl, that there's one chlorine atom, okay, like that, and it actually has 3 oxygens attached to it, like that. Okay, and they actually all together have a negative charge. They have 1 extra electron than they do all protons together. Okay, so please watch the Tyler Dewey videos that also recap ionic compounds, naming them, what's ionic bonding, and then how to write their formulas and their names. And then there is a video about polyatomic ions. And then there will be a video about molecular compounds. Okay. Other than that, I hope you guys have a great week. See ya.